So we're going to take a peek today at using the different forms to be able to solve these systems. And yes, you need to be at least decent with all of them because you can't just use the exact same one for every single one of these. Nice thing about this first part of the review when we're doing the graphing, everything's in y equals for us already. So just a reminder up here at the top that once we're in y equals, my y-intercept is always going to be that number hanging out on the end. It's going to tell me whether I'm going up or down on this axis to make my first point. And then my second part is going to be dealing with the slope, which again is our rise over run. Our, how much am I going up or down versus how much am I going left or right. And I might even go ahead and put that in here. Now again, this is something you'd have to know when it actually comes to the test, even though you can, like we've said before, you can use your examples if you have them somewhere still. That's never going to be a problem. But I would hope at this point that we'd have done this enough, I guess I'd say, to work through this and be able to do it with pretty much some ease at this point. So when I'm doing these, my whole goal when I'm plotting all my points is to find a point that each of my lines have in common. If they ever cross, that is, because occasionally we'll run into that too a little bit. But hopefully the graphing part isn't the issue, it's just trying to figure out what that point's going to be. So what I'm going to do to try and make things a little more obvious as we're doing this, and you have this option too if you'd like, is I'm just going to use different colors for my dots so I can see a little more easily when they cross each other. So as I'm doing this, my value on the end is always my y-intercept. I got to pay attention to the sign though. So if it's -4, it's going to mean I go down 4. Okay, if it's plus, I go up. So then 3 over 2, let's see, +3 means I go up 3, okay. Don't put the dot yet though. And +2 on the bottom means I go right 2. So up 3 and right 2. And I'm going to run out of room. I'm over here somewhere. And I don't have any more room down here, so we'll have to discuss that issue when we get to it. So I got my dots there. Hopefully I find one on this other one that works the same way. I see my y-intercept on the end. My number on the end is positive, so I go up that many. Put a dot. Here's the part that gets tricky. I got this negative in front. And I'm like, well, does that mean it's -1 and -4? Does it mean I get to pick? What exactly does this mean? I get to pick, but it's only going to be on one of these. So typically what I'll do is I'll go ahead and I'll just put it on the top number. But if I put it on the bottom one, that would work. So -1 on top means I'm going down 1. +4 on the bottom means I'm going right. 1, 2, 3. Hey, there we go. So I notice right here, there's my point where they cross. So what's the value of that point so I can put my answer down? What are the coordinates of the point right there? How many do I go over, and then how many do I go up? Okay, so we go over to the right 4. So that's my x value, because I did that on the x-axis. And then I went up 2. And you need to be able to tell me what that point is, because otherwise, well, there's no use in this, because it's the numbers of the part that I'm actually looking for an answer. So whenever I'm doing that on any of these, same idea is going to run. I look at the plus or minus to figure out if I go up or down that number. If I get a slope that isn't a fraction, now that's kind of important, because I don't just want to go down 5 and put a dot. So what number can I put under the -5 if I don't see one? Did I put 0 underneath it? 1. Okay. So I'm like, okay, how's this work? Down 5, 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4. I'm a little off here, but I still can squeeze one more in there. Just put as many as you can to fill in your graph. And again, I go down 2. Okay. If I don't see a number in front of x, we've talked about that before. It's just going to be 1. So I go up 1 and right 1. Oop, there's my point. Up 1 and right 1. Up 1 and right 1. Okay, I can get my points in there. But I've already found my spot where they cross. It's that guy right there. So the question becomes, how do I write that point where somebody could find it? How many do I go over? How many do I go down? You know, we go right 1. I even see the number right there, 1. And I go down 1. I see the number there. And I'm set. So for all of these, they are going to cross somewhere unless they don't cross at all. So that's kind of what we're playing with here. Do number 3, and then I'm going to, actually, I want to do 3 and 5. I'm going to leave 4 here for a little bit. So 3, same idea. Using different colors is just a good idea so you can tell which line's which. So where am I going to start for my black line on this one? What's my y-intercept up here? -2. So I start down 2. And then I look here and I'm like, oh yeah, and we talked about this before. I'm going to treat it like it's -5/2. But here's my issue with that. When I go to, okay, nope. Oh wait, they're all, nope.
All right. Thank you.
Absolutely. So, when I go here, I'm like, well, wait a minute, that's going to be a problem because this would be down 5 and right 2. Well, I can't go down 5. Bless you. So what do? Yeah, I can do the opposite of both of these. I can go up 1, 2, 3, 4, 5 and left 2. If I'm going to do this, and I can't, I have to do the opposite of both of them. So up and left, and I really can't put any more points in anywhere. So hopefully one of those 2 points works for me. And then I worked the other one. Wait just a little bit. When we get set with this, then we should be good. Same concept here. I'm just going to put the negative on the top one. We'll see if that works out for me. So I'd go down 1 with the negative on top, and right 2, down. That didn't help me. I didn't run into it yet. So just like before, if it was down and right, I can also go up and left. Oh, there we go. And find my point. And once I do that, again, I start back at the origin and I say, okay, I go over to -2 and I go up to +3. And I'm ready to roll. I'm good to go. One last one I want to take a look at with you. So I want to show you a possible little shortcut that can help you occasionally on a problem. And if we look at 5, that's the one where we might be able to make life easy on ourselves. So I look and I say, okay, this doesn't look really abnormal. My y-intercept is up 4. That first point, always looking for somewhere on y here. My slope is 4/1 because I always want it to be a fraction. And I'm like, well, but I can't go up 4. Okay, but remember, up and right can be the opposite, down and left. down and left. I can do the double opposite and still get some points on there. So then I look at my red one. I'm like, okay, start at 1. Huh, interesting. It's 4 over 1 again. 1, 2, 3, 4, 1. Ran out of room that way, so that's okay. Instead of going up and right, I can go down 1, 2, 3, 4. Uh-oh. They're not crossing at all. The reason for that is they have the same slope. And we talked about that before. If they have the same slope, they're not going to cross. So if they never cross, or if they have the same slope, and I notice that right away, I could just say, oh, same slope, no solution, I'm done. Probably could even get away with that without graphing them. But it's good practice to be able to graph them too. So I'm going to leave number 4, like I'd said before, for now, because it's always good to have one for yourself to kind of see how things are going. And we're going to flip over here and get back into some of the actual math stuff that we did before. Now with these, we remember, oh yeah, we look to see if one of these is solved for x or y already, and we're going to plug that in. And so we typically, we're putting a box around the side that didn't say x equals or y equals to remind us, oh yeah, I've got to plug this in wherever this variable is. So this says y, so I'm going to plug it in where the y goes. And why I chose to make every single one of these y, I don't know why. So when I'm doing substitution with these, basically what I'm going to do is I'm going to rewrite the equation I'm plugging into. But when I get to that variable that I'm substituting for, whatever's in the box, I'm going to replace with, take out the y, notice the 7's still there. All I took out was the variable and replaced with what's in the box. And now the only variable I have left is x, so I can solve for it. So I see parentheses, and I'm going to distribute. 7 times negative 7 is negative 49. 7 times 11 is 77. And now I just start working my way through the regular algebra process of this, looking for like terms or things that I can do to work on getting x by itself. Well, I see first that I have 2 x terms. I need to fix that. And again, watch for signs and use the calculator if you need to. I have 3, and I have a negative 49. It'd be negative 46x. And again, make my lines here so I can make sure I keep separated. And the ones that I've got for you on here should come out nice. And again, I'm multiplying by the negative 46, so don't add it. Get my x in this case, since that's the only variable I had left. And then my second step is always going to be plugging that value that I just found, in this case for x, back in. And figuring out what y is. And again, typically on these, we'd put the answer in a coordinate just like we did with the graphs then. So it just gets to be a process that you work through with all of these. And I'm just going to kind of keep working down here. So I'm going to do number 6, excuse me, we just did number 6, number 8 and number 10 with you, and then I'll leave a couple for you to kind of play with too. So again, we're going to plug this in. So I got 3x plus 2, don't forget that 2 is still there. We're going to plug this in for the y. And again, when I'm distributing, I'm multiplying. It's those little detail things that can get us at times if we're not careful. Combine those like terms, so I'll put my x's together. They're both positive, so I can go ahead and add them up. Oops, forgot my equals in there. Now that would have been a problem. Again, I just keep doing my opposites. The opposite of multiply is to divide. I get my x. And just like we did before, we're going to just plug that into the box here, plug in the 1 for the x. And the biggest thing with this whole process is, are you going to go slow enough to allow yourself the opportunity not to make a silly error somewhere? That's my hope for you. I can get some of you to slow up. Now, the test itself is not as long as the review is, so you're going to have plenty of time to be able to do what you need to, as long as you've practiced some of this to a point where you can, you know, do these. Okay, one last substitution here. Again, we're going to plug in. It's y equals, so we plug in for the y. I see parentheses, which means I have to distribute. Now here I have to be careful, because negative times negative is positive. And if I don't watch out for that, I'm going to run into a different issue. Negative times negative is positive. Opposite signs, so 24 minus 5 is 19. So notice I'm not trying to do multiple steps at a time, because all that's going to do is make life hectic for me. And now it just becomes a point of working my way toward solving this guy. Again, it's all about signs. If I forget the negative on that, I'm going to mess up my y value because I'm plugging the wrong answer in. But that was the hard part. Once I get to here, this should be the easier one, because there's really going to be no solving. It's just going to be me plugging numbers in the calculator. Negative times negative is positive. Get my value, and I think I can squeeze my coordinate in over here. So we're just plugging in, substituting, simplifying to get our variable, and then plugging that into the other one. And a lot of times this might actually be the longest one that we do. I think elimination actually goes faster. So if we can survive those, not bad. Again, we'll leave you a couple to be able to do on your own and kind of see how that's going here in a bit. And then the last one we worked on, our third one, is elimination. And again, not only these, but some of the story problem types like we were working on towards the end of last week. So when I'm doing elimination, always try adding down first, because if I can add down and eliminate a variable right away, well, shoot, I'd rather do that. So let's see, negative 6 plus 8, yep, that's not going to cancel. Negative 3 and 3, nice, okay. So they cancel right away. And I'm just going to add down. Negative 6 plus 8 is 2x. Negative 3 plus negative 3 is negative 6. That's nice. No distributing, no like terms, no nothing. I just got to divide by 2 and I'm going to have a variable already. But again, there's 2 variables, so I'm not quite done yet. Typically what we'd been doing is we kept taking the top equation and working with it. And I'm just going to keep doing that. So I've got -6, but I know what x is now. So I'm going to replace the x with its value. And I'm just going to copy the rest. Lots of -3's going on here. Negative times negative is positive. And now, once I've got that set, I've just got to work on getting the y by itself. Since I'm doing a positive 18, and since that minus in the middle, I'm adding it, I'll do the opposite. -3 plus -18 is -21. And again, this is multiply. I know I see the minus there, so you might think about adding, but I'm multiplying times the -3, so I got to do the opposite. And it's always x then y. And of course I need to change things up, so we're going to take a look at number 12 next, but we're fortunate that the same thing happens again. -3 and positive 3x I see cancel right away, so I'm just going to go ahead, wipe them out. 9 and -4 is 5. -15 and -10 is -25. It's the nice thing about elimination, they're much shorter when it comes to finding that first variable. But I have to make sure that I'm being cautious with my signs. Because again, if I screw up a sign on the first one, there's no way I can get the second part right. And then I'm just going to continue to keep taking that top one. But notice this time it's y that I know. I can't plug it into either one. I got to plug in for the right variable here. And now again, it's just detail work. Am I going to be careful enough not to make an error? 9 times -5 is -45. I want to work on getting x alone. So I'm going to add the 45 to that. Oops, that's positive 30. I almost made an error myself. And again, just like before, we're multiplying, so we'll divide. And again, I'm going to leave you with a couple where you can just add down so you can kind of get some practice and get into the flow too. Because it always looks easy when we do it together, but then when you go and do it on your own, sometimes it can be a little trickier, but you've got some ways to be able to look at some answers this way. So finally, we get to the back, and we have a little bit different of an issue. Because when I get back here, I can't just add down and eliminate a variable. It doesn't work for me. So I got to start looking at this, and I say, okay, let's see here. Ooh, I see a couple I want to do. I want to do 18, we're going to do 15. Okay. If this were a perfect world, since this was -3, this would be +3. If there's a way I can do that, that's a simple way to go after it. So if this is -3, my God, and I've got a sleeping horse in class. I didn't know I was out in the barn. So here, if I multiply this by 3, all the way through, not only to the one I want to change, but also to the other two that I have. and I'm going to leave the other one alone, because I got everything I needed from doing it on that first one. Because now when I add down, negative 3 and 3 cancel. Negative 10 plus 60 is 50, and negative 4 plus 54 is also 50. And I can get to a solution that way. Now I still have got my second step with these that I need to do. I still need to know what x is, so I am going to keep doing what I've been doing all along. I'm just going to keep going with the top one. Now some of you may say, well, the bottom one looks easier. I say go for it then. So I've got negative 3x minus 10y negative times positive you'd be getting some benefit from this, but I'm not sure you are. And again, I always want to make my coordinate work that way. So for any of these, if I can't add down right away, I'm going to have to multiply by something to get what I want. So I have to think about what I want to make these work. So on this other one I've got starred, if I add 8 and 16, that doesn't cancel. 2 plus 5, that doesn't cancel. But in a perfect world, I would like this to be negative 16, because then they'd cancel. Well, I can multiply 8 by a number to get to 16. I could multiply by negative 2. And if I'm not sure, again, play with numbers on the calculator to make it work for you. And that negative 2, though, has got to go all the way through. And then I'll just leave the other one alone. Negative and positive 16. Okay, now I get what I want. That's what I'm talking about. Negative 4 plus 5 is just y. Well, that's even better. 32 minus 28 is 4. So I've got my y value already. And just like we've done before, I'm going to take that top equation, and it says y equals, so I'm going to plug it in where y goes with my 4. And now I'm just going to simplify this, and I'm going to be done. And I'm going to go ahead get my value solved for and put it into its coordinate form. And then just to put some of you at ease with what we were doing at the end of last week, there are going to be some story problems on here, but you're only going to be asked to set them up. I do believe on one of the questions I made it extra credit if you did go ahead and solve it, because again, it's an impressive feat to be able to do that. But our big thing here is just setting up the system. So like here, we got 2 senior classes at high school A and high school B are taking separate trips to the indoor climbing gym. This one rented and filled 4 vans and 1 bus with 44 students. B rented 12 vans and 5 buses with 172. So I always got to look and see what are the 2 things I'm working with. So here it would be vans and buses. And then basically I just see what each one's going to be. So I got 4 vans plus 1 bus is 44 students. And then it looks like my other one is 12 vans plus 5 buses equals 172. That's what I want. That's all you've got to do on these is get those set up and ready to go, and then you're good. So again, you got a couple problems in each of the sections to be able to use the examples to work you through. The test will be similar to this. It's going to be somewhat close in size, but it won't be quite as big. And then it gives you a little bit of time here to also play with your homework check, or